Hello and welcome to another exciting Saturday session at John Trappell Natural Philosophy Society. Once again, we'll be attacking Einstein's relativity, but first I'll show a fundraiser.
Hello everyone, I'm David D. Hilster, President of the John Trappell Natural Philosophy Society. During the past 2 years, we have used annual fundraising drives in order to keep our organization's presence alive and well on the internet. Both years we have been successful in that the monies collected have been enough to keep us afloat. This year is our third annual online fundraiser, and once again we are counting on your support. But first, I want to thank everyone who pays their annual memberships through our automatic online system. Your support is vital and provides us with important funds to keep the CMPS afloat. Hopefully, as we continue to grow, we will be gaining more and more automatic memberships so that these fundraising events won't be necessary. But we are not quite there yet. This year, we will be implementing several changes to our online system. Several to save money and lower our annual expenses, and another to better our discussion platform. First, we will be moving our websites and databases to another server that has graciously volunteered to host us at a much reduced rate. It currently costs us $1,400 a year for our dedicated server, given that we need complete control over our own software. The new server will give us and allow us that control, but only for $250 a year. Second, we will be moving away from BuddyPress, which is a Facebook-like plugin for WordPress, to using Discourse. BuddyPress was an interesting experiment, but the upkeep of the plugin and its general design don't really fit what we need. What we need is a robust and well-accepted discussion forum, and that is why we'll be moving our online discussions to Discourse. It costs $20 a month, which is half the price of BuddyPress. I think those currently active in our online discussions will find this new platform much more enjoyable and functional. Third, we are moving to a free version of Overleaf, which eliminates a $33 monthly fee. Overleaf was useful for us when we were publishing our own proceedings for conferences, but that is no longer needed. Our goal this year is $2,000, and I hope we can reach that goal. Whatever amount you can donate, it is greatly appreciated and needed. Your membership and donations are vital to keeping our online community of critical thinkers alive and well. To donate, go to fund.naturalphilosophy.org. That is fund, F-U-N-D.naturalphilosophy.org. Thank you, and keep up the amazing work that is driving science forward.
Well, hello. So we're back from that. Please give us some money. So today's talk is called Newtonian Physics due to Einsteinian Physics. And I criticised Einstein's physics relativity quite a lot in other sessions. And one of the criticisms I have is it's not really that clear when you're switching over from Newtonian physics to Einsteinian physics. So let's get into this issue. Now, I'm going to be using AI, artificial intelligence, and the reason is when you read all the literature that you can on relativity, there still remains questions that are unanswered by those texts. So I'll go into AI, artificial intelligence, to try to answer some of those questions about relativity. When initially talking to AI, it would say how wonderful relativity is. It wants to take the mainstream point of view on things. But if you properly interrogate AI and say why you think relativity is wrong, it will start agreeing with you. It seems to be, it wants to be friendly, it wants to agree with the person that it's talking to. And so it seems to adopt the person's point of view on the subject. And my point of view is mainly opposed to Einstein's relativity, and so it sort of like then starts to agree with that. So this is the sort of setup given by relativity for time dilation, and one of the issues us distance have is, well, it's not really time dilation, it's not an effect on time, it's really an effect on clocks. But besides putting that issue aside, what you have is some maths that is dealing with the time for different observers, and what you have is light bouncing between two mirrors as shown here in this picture. And so the light is bouncing upwards and then bouncing back down from the mirror, so it's from light source to mirror to receiver. And the person who's stationary with respect to their setup will think the light just goes up and down between these two mirrors. But if the light source is moving relative to an observer, then what happens is the light is following this trajectory as shown for this observer on Earth. It's going up at an angle, hitting the mirror, and then bouncing back down again. Because what's happening is the mirror is moving, and the mirror has moved to the different position for when light hits it, when the light's going up at an angle, and then it's bouncing back down again, and the receiver or light source has also moved. So in this setup, as per what the observer on Earth is seeing, he's seeing light going this triangular path. And this is what is a standard thing usually shown in relativity textbooks. And so you can put a bit of maths on that. You can say the distance up is s, and the length is L as shown. Well, it's 2L, I think, in that one. The light along the bottom, the distance along the bottom is 2L. Let's go on to the next slide. So this is the picture in a bit more detail. So it's the distance up is D, and the distance the light is traveling is 2L along the bottom, and it's traveling up a distance S and then bouncing down from the mirror and traveling another distance S. So that's what it looks like. And you're treating the whole setup as moving with velocity v along the bottom there, along the which is what normally called the x direction. So what you call a NASA scientist on Earth sees the light follow the longest path to S and takes a longer time, delta t. And that's opposed to what the astronaut would see, because the astronaut sees just the light bouncing up and down. He doesn't see light taking this triangular path. So from the triangles, we can form this equation. Along the hypotenuse of the triangle, we've got this distance s, which is the square root of d squared plus l squared, close brackets. Normally you've got bracket d squared plus l squared, all of that square rooted. And these triangles are used to find the relationship between the two distances d and s. So substituting the values into the distances s, d, and l, you've got 2s is equal to c delta t, 2l is equal to v delta t, and 2d is equal to c delta tau. but I'm going to write it as dropping the use of the triangles because that's a bit of a nuisance. As long as we carry on knowing we're talking about intervals here, we don't really need to put the triangles in. And instead of the tau, I'm going to use the t dash. So 2s equals ct, and c, by the way, is the speed of light in vacuum. 2l is equal vt, and v is the speed along which is the x-axis, and 2d is equal to c c t dash, and normally say the dash is a prime, so it's c t prime. So you've got 2 times here, you've got the t time, and you've got the t prime time. So highlighting it again, this is the equation you have, and if you rearrange that, you end up with the equation for time dilation, or I'm calling it here clock time dilation, and that is t prime is equal to t, and that's divided by 1 minus v squared divided by c squared, close brackets, and that's square root of that. So that's what the relationship is supposed to be for finding the time intervals between the two observers. The one observer is observing this what is called a light clock as being stationary, and the other observer is seeing this arrangement moving. So they're supposed to be observing 2 different time intervals. However, there are some assumptions made in forming that equation. So going back to the triangle setup, speed along L is v, but y assumes speed along S and D are the same speed c. C is the speed of light. So they want to, in the relativity text, they want to assume the speed of light along S, and the hypotenuse is c, and the speed of light along the vertical D is also c. And so making that different. And so I'm making that different, and now that's saying that 2s is equal to ct, and 2l is equal to vt, and 2d is equal to c prime t prime. And so I'm introducing this speed c prime, and c prime is along the d direction and c is along the s direction. But normally in relativity text, they're assuming that c prime is equal to c. So now in my setup for the maths, I've changed it to being that you have a t prime and a c prime in the maths, so I'm expanding on what's normally given. So substituting into the equation, you end up with this equation being shown here. If c is equal to c prime, then it gives the usual clock time dilation equation, the same as before. But now, if instead of doing that, you set t as equal to t prime and have light speed is variable, what you end up with is this equation, c squared minus v squared is equal to c prime squared. So equation with the c prime is shown here, and it gives the time dilation, clock dilation equation if c equals to c prime, with t not equal to t prime. But the usual treatment of light in Newtonian physics is it would be the speed of light would not be constant, and so c prime would not equal to c. So I'm saying that right. C would not equal c prime, and instead of having t and t prime different, you would say t equals to t prime. So thus, we can see that Einstein's postulate of light speed constantly thus is, in mathematical terms, making the assumption that c is equal to c prime in this equation I shown at the top of this slide. So I just make sure everything's going all right. Hold on a moment. Sometimes when you give these talks, things start going wrong. You don't find out about it until later. Yeah. So I think it's going all right. So going back, carrying on. So, as I was saying, Einstein's postulate light speed constancy thus is just this maths of saying that c is equal to c prime in that equation I'm showing you at the top of this slide. And that's contrary to how Newtonian physics would be treating it. It would be treating light speed as not being constant. It would be saying that c was not equal to c prime, and it would also saying that the time intervals for both observers would be the same. So it would then be saying that t is equal to t prime. So you've got this conflict of what you can deduce Einstein is saying that in this equation, which is shown, he seems to be saying that c is equal to c prime with t not equal to t prime. And Newton would be making this distinction of saying that c was not equal to c prime and that t was equal to t prime. So that seems to be a fundamental split between how Einstein wants to deal with this mathematics from how Einstein is dealing with it. So you can ask AI what it thinks about that, and I'm saying artificially because AI doesn't really think. It's some sort of complicated algorithm. It doesn't do the same as people and actually think, but it's doing something equivalent to thinking. So it's artificially thinking of things. But in my case, I want to know, ask questions about relativity, which is not in the relativity textbooks or in other relativity papers. Particularly, I want to ask it about this issue of why is Einstein saying that, well, why is Einstein saying c equals c prime? I'm not saying that that's what he seems to be saying. He doesn't explicitly say that, but what we can do infer is that what he seems to be saying when he talks about light speed constancy. And so why would he do that when it conflicts with how Newtonian physics would be doing with it? And that sort of question is not in the relativity text, so relativity literature. So I want AI to try to answer this question for me. So after dealing with AI defending Einstein relativity because it's got that bias, it wants to uphold the mainstream point of view on things, I then get to give it my thesis that the maths of relativity, it can be manipulated back into a form Newtonian physics likes. And AI agrees with me. You can manipulate the maths. And so there you go. The maths can be manipulated back into what Newtonian physics is dealing with. And AI agrees with me. And so AI says, yes, and this is actually one of the deep insights of physics. Newtonian's laws aren't discarded, they're recovered from Einstein's Einstein's theory, when you manipulate the maths under certain assumptions. So you've got this general mathematics. So I go back to that equation at the top. That's the general equation of the mathematics. And you can manipulate that in various different ways. And if you manipulate it one way, you say get Einstein's relativity. But if you manipulate it another way, you get it back to what Newton was dealing with. When it's more like Newtonian physics, when you've got C prime and C as not being equal. There we go. So AI goes on to say Einstein's theory contains Newton's theory as a subset. So I take that to mean that Einstein it's trying to tell me in its artificial thinking way that Einstein's theory is the more general theory, and Newton's theory is part of that more general theory of Einstein. AI goes on to say Einstein's equations are more general when you simplify them by removing terms that are only significant at high speeds or in strong gravitational fields. You get Newtonian's equation. This is not a flaw, it's a little bit side feature of good theories in physics. So it's in AI is trying to defend this bit of mathematical manipulation of changing things from how Newton deals with, Newtonian physics deals with things to how Einstein seems to want to deal with things. It's formulating the maths in a way I disagree with, so I want to bring in the equation, which I mentioned earlier, of open bracket CT close bracket squared is equal to open bracket C prime times T prime close bracket squared plus open bracket VT close bracket squared. So that's the basic equation. So I want to know why it's manipulating the maths of that equation to give what Einstein seems to be wanting to deal with for that equation. So as I'm pointing out, the relevant equation is the one I've just pointed out. And if you place C prime is equal to C, then T and T prime are different. And that is relativity. But if you have T is equal to T prime, then C and C prime are different. So Newtonian physics and relativity are connected by this equation as to how you want to deal with it. And AI responds to that by saying, that's a very interesting formulation. You're essentially describing a relationship between time coordinates, velocity, and the speed of light. That frames the connection between Newtonian and relativistic physics. Let's unpack this carefully. And so, step one, understand what this implies. This is AI. Let's isolate the key pieces. C is the speed of light in one frame. C prime is some speed in another frame, possibly also intended to be the speed of light in that frame. V is the relative velocity between frames. T prime are time coordinates in two different frames. You noted if C equal to C prime, then T does not equal to T prime, and that gives the time dilation of relativity. And as I pointed out earlier, some distance say that it's not time dilation, it's really clock dilation. But putting that issue aside, and it says if T is equal to T prime, then C does not equal to C prime, and that's variable speed of light, non-relativistic or Newtonian thinking. And so it's pretty much summarized what I've tried to point out, that just depending on how you're going to deal with C prime and T prime, you can recover Newtonian physics. And so it's sort of like just summarizing that there. Step 2, and this is AI still. What does this tell us? Question mark. And it says, this is a clever way of illustrating a key philosophical fork between Newtonian and Einsteinian physics. And by fork, it means you can go in two different directions here with how you're treating the variables of t, t prime, c, and c prime. In Newtonian physics, time is absolute, and that means that t is equal to t prime. To make sense of motion, one must allow that the speed of light can differ between observers, or more broadly, that there's no universal speed limit. So the way you've handled that fundamental equation, which I pointed out to you, it depends on whether you can just carry on treating it as Newtonian physics. In relativity, the speed of light is constant for all observers, and that is c is equal to c prime. To make this work, we must give up the idea that time is universal, hence t prime doesn't equal to t. So t does not equal to t prime. And so that's breaking the time dilation idea. So that's supporting the time dilation idea of relativity, and it points out the usual idea of simultaneity breaks down in relativity when you do that. So it's two different points of view, Newtonian physics and relativity, and how you're dealing with the maths. You've got a dual between Newtonian physics and relativity, just depending on how you've got to deal with the maths for that equation. You've got Newtonian physics as dual to relativity and vice versa. So they're pretty much dealing with the same thing, but in a different way. So step 3, your equation as a bridge. By bridge, it's sort of like talking about how do you connect Newtonian physics to Einstein relativity. And it says you've written an equation that reflects a trade-off. If you insist on a constant speed of light, you must let time vary. If you keep time fixed, light speed must vary between frames. And this is exactly the conceptual leap that Einstein made in 1905. So it quotes this: the laws of physics are the same in all inertial frames, and the speed of light is the same for all observers, regardless of their motion. And as I pointed out, that is changing. That is a change made by saying that c is equal to c prime, and having t they're not equal to t prime, and that's a change to how physics was dealing with such an equation. So with a type equation like that, it would have been dealing with c is not equal to c prime. So suddenly Einstein, it appears to be, is making this big change in 1905 from how such an equation would deal with things. And so it says AI says of this, to preserve this, which is Einstein, redefined time and space, which leads to Lorentz transformations, not Galilean ones. So basically, with this duel between Newtonian physics and relativity, Einstein just decides to change everything. Suddenly, you've got, in the existing way, you've got c as not equal to c prime. So Einstein decides to change that to being c is equal to c prime. And I'm pointing out now this is inferred what he's doing, because he doesn't explicitly say this. And so he's suddenly doing this c is equal to c prime, and then he's changing everything else. Everything else he's changing from how Newton's dealing with it, dealing with time, and so forth. And so AI is summarizing, you're absolutely right that Newtonian physics and relativity are connected through such relationships, and the equation you propose reflects the core tension in choosing which quantities are invariant and that's fixed across frames. And so Newton says time is absolute, speed of light is not necessarily fixed. So that's what, if you've got two observers, then that's what they're saying. Time is absolute. The observers are saying time is absolute, and the speed of light is not constant. And that's in the Newtonian context. And so both observers will be agreeing on time intervals, but they would be both agreeing that the speed of light was not constant. Whereas with Einstein, he would make speed of light is constant and time is relative. So that's the switch that's being made in this mathematics. Suddenly, by making c equal to c prime instead of the usual way of treating that speed, you've suddenly switching things around. And AI says that single equation you posed captures a profound choice, and your analysis of it is conceptually rich. So my point then is Newton did talk about relative space and relative time. Newton was not confined to just talking about absolute space and absolute time. He did talk about relative space and relative time. He did try to consider that issue. But going with the AI representation that Newtonian physics is absolute space and absolute time, while relativity is relative space and time, we see in this equation how the two things are connected by assuming either c prime does not equal to c, or assuming c prime is equal to c. I asked AI then for further details. AI, artificial intelligence. So Einstein physics and Newtonian physics is dual by this, and it should be a question mark there. And AI says yes. Beautifully put. You can think of Einsteinian physics and Newtonian physics as duals. So they are connected by this. Connected through a fundamental trade-off in what is held constant and what is allowed to vary. So relativity, duality, what you hold fixed and what you let go. And this is what AI gives me. And so it gives the principle, and it tells you what the Newtonian physics version of it is, contrasted with the Einsteinian relativistic physics version. So time in Newtonian physics is absolute, and in the mathematics that is t is equal to t prime. Whereas if you went with Einstein, you would have time as relative and t would not equal to t prime. And the speed of light in Newtonian physics would be variable or not central. I'm not quite sure what the word central means. So Newtonian physics is treating that as variable, but if you go to Einstein, he's treating it as absolute, and he then has c is equal to c prime. And so for the transformations in Newtonian physics, you have the Galilean transformation, and if you go to Einstein, you have the Lorentz transformations. And so you then can go on to the idea of the space-time view. In Newtonian physics, you're treating space and time as separate, but in Einstein, due to what Minkowski said, which was later than 1905, Minkowski came out with this theory, I think about 1909, and you have Minkowski space-time, where space and time are unified space-time. And the next issue is causal structure, and in Newtonian physics you have universal simultaneity, and in Einstein physics you have no absolute simultaneity. So you have this duality between Newtonian physics and Einstein physics, just based upon this fundamental equation I've just shown you. And now next it wants to go on to the philosophical interpretation of this. And AI says this duality reflects a deeper truth in physics. No observation is absolute, only relationships between observations are. The laws of physics must stay consistent, but how we interpret quantities like time, distance, and speed depends on our frame of reference. And so my point on this is relativity has been misunderstood. And it's the reason why it's not been misunderstood is because we go back to here, it's not really properly understood the duality that's going on here between Newtonian physics and Einsteinian physics. And it goes back to this fundamental equation. I'll bring it back up again. I wonder if we go back. Oh, that one went blank. It doesn't like me going back too far. But that fundamental equation, which I showed you some time ago, that's what the issue is about. My slides have been shown as black now because I've gone back too far in them. So hold a minute, hopefully it will come back again. Okay. No. I'll remove that from stage and try adding it back to stage again. There we go. That's pretty annoying. The slides have gone blank on me. So StreamYard gets temperamental at times and does these funny things which I don't understand. It's played up before in the past for me when I sort of like giving audio. It's played up my audio and things. And then it plays up about my accessing onto StreamYard. So I tried to start again. Okay, so we're back again, but I lost my place. So, yeah, so I managed to get back. Let's get back to the philosophical interpretation. I hope that's where I left off. So my point on this is relativity has been misunderstood because of this duality issue not being highlighted. Yeah, and that's it. That's the end of the talk. I forgot to put the finish on the last slide. If I can get back to that equation again. Which AI is calling a bridge. Let's get back to it. Yeah. So it's the top of the slide here. The relevant equation is c squared. I know that's not the general form. Let's go back further. Yeah, it's the. I think I can show it better elsewhere. No. Yeah, so it's the equation at the top here of c t, all of that squared is equal to c prime t prime, all of that squared plus v t, all of that squared, and that's the equation. How that equation is treated depends on whether you've got Newtonian physics or what you commonly think of as Newtonian physics. How you treat that equation is how commonly you can end up with what we commonly think of as Newtonian physics. But if you treat it a different way, you can end up with what we think of as Einstein's relativity. So you've got this duality of how you're going to treat that equation. You can treat it one way as Newtonian physics, and you treat it a different way, and you end up with Einstein's relativity. So that's the end of the talk. The equation there is most fundamental, in my view, as to what relativity is and how Einstein seems to have treated that equation is what's I think is causing all the mess in relativity. I mean, why would he suddenly decide to treat that equation differently to how it's normally treated? And I say that because in the sense that Einstein did not explicitly state that equation. We can infer that's the equation which Einstein has decided to treat differently to how Newtonian physics would treat it. And what would have been good form Einstein would be to have explicitly stated that equation and said, oh, Newtonian physics is going to treat that equation by having C and C prime is different, but I'm going to treat that in a different way and have C is equal to C prime. But he did not explicitly state that. And so he's left all this confusion of how you are changing from how you're dealing with the maths in the Newtonian physics to how you're dealing with the maths in his relativity. So thank you. I'll see now what we've got in the comments. So Nick disagrees, and that was at 3:38. So is he there? He has not put his hand up to talk. In the private comments, Nick is disagreeing. So I look at the general comments in YouTube to see if anybody's dealing with what I'm talking about. Oh, Nick's put his hand up. Let's have a look. Hi, Nick.
Hi, Roger.
Hello.
Now, I've listened to a lot of your talks, and they've been great. And you've also brought in and made us aware of a lot of very interesting papers and videos by other people. However, this one, I strongly disagree with, very strongly disagree with. So hopefully that won't cause a lot of personal animosity. I think the whole thing is much simpler. Are you familiar with the Lorenz's theory?
Yeah, Lorentz, yeah.
Because to me, this is very misleading, and in the sense it's sort of the key thesis of the NPA and the CNPS creates a very strong reaction with me. I think things are very simple, but they're not mathematical. The problem Einstein made, in my view, is when he went from Lorentz and took all of Lorentz's equations and misinterpreted them. He was thinking in mathematical terms, and he was not really thinking about what he was doing in terms of making a major change in physics. There was classical physics, which was extended by Lorentz to high-speed phenomenon, to a totally different, unrelated theory, which had the same math equations, but the big point was what happened in the physics when you made this transition. And to me, it's very simple. Lorentz said that there is a single preferred frame in his physical model. And that single preferred frame was the ether rest frame. And motion with respect to that frame caused various specific physical phenomenon that were a function of absolute velocity with respect to the single preferred frame. And then what Einstein did by misinterpreting the relativity principle to be that there are no cannot be such things as a single preferred frame, to having every inertia frame be the single preferred frame, which is absolute nonsense, self-contradictory. And that's what the problem is. Now, relativity was saved to a bit because there are a number of things that are Lorentz invariant, so that physics error that he made doesn't always show up, except, when things like when you have GPS or whatever. So to me, to look at it from a math perspective is making the same mistake that Einstein made when he went from classical to physics to relativity, which was a non-physics or very deeply flawed physics theory. So to think of it in terms of math going backwards, I think I would just claim, from my personal opinion, that that's not the right way to look at it. The right way to look at it is Einstein made a major physics model shift when he went from Lorentz's view, Lorentzian ether theory, to relativity. And I don't see any duality except for a math duality, but from a physics point of view, there's not a duality there.
Okay, no, so Einstein didn't contrast when he's writing in 1905, when special relativity is supposed to have started. He doesn't say anything about Lorentzi's theory. So we've got nothing from there of how nothing from him saying how he's going to deal with things differently to Lorentzi's theory. There's nothing there. All we have is he seems to be working from Newtonian physics, and then he wants to do things differently, but he has not explicitly stated what the steps are that he's making. And
yes,
all we really have is the mathematics, what we have from Newtonian physics, and we have the mathematics that Einstein is presenting in his 1905 paper. And all we've got is, well, how is he dealing with the mathematics differently to how Newton's dealing with it? And as I pointed out, the difference seems to be about the light speed constancy postulate. He seems to be making the math claim that C is equal to C prime based upon that postulate, and that is going against what Newton is doing in his physics. In his physics, with his mathematics, you have not got C prime as equal to C. So suddenly Einstein is making this mathematical shift in how Newton deals with the mathematics and how he's dealing with the mathematics.
Wait, hold there for a second.
Sorry. So he's making this fundamental change, but he's not explicitly stating what this fundamental change from the way Newton is dealing with the mathematics to how he's dealing with the mathematics. And as
right, the problem has always been that he didn't explicitly make the change of what he did in terms of physics. And what he did, I'm just, before you go on for a long time, let me just respond to what you're saying.
You go on for a long time. You just
no
on for a long time, and you went on and on and on. I could have interrupted you, but now you're not letting me talk. And basically, with physics, it is mathematical, and basically that is going against your philosophy. And so basically this talk has been about the mathematics and trying to make sense of the mathematics. And you want to say, oh, it's nothing to do with mathematics. You just want to go on to some other issue. This issue has been about the mathematics, but you don't want to address that. And the issue is, how does the mathematics change from Newton to Einstein? And Einstein didn't explicitly state it. And also, Einstein didn't explicitly state anything about Lorentzi's theory as to if he wants to do things differently. So you just want to go on to lots of other side issues.
All right, I'll respond to that. Yeah, the problem has always been on the focus of math. As I say, the fundamental problem that Einstein did was he didn't talk about the physics change. He took Lorenz's equations, including the Lorentz transformations, and made a fundamental physics change that he didn't explicitly talk about. But that is the key insight, that the change that he made was changing the Lorentz ether model, having a single preferred frame and its absolute velocity with respect to that single preferred frame, which is what is actually physically happening. And he changed it to being observer-centric and saying that all of these contradictory different views by different inertial observers are equally physically valid, and that's not true. So the physics got lost when he took the math equations and reinterpreted them. But the key insight is, what was the physical change when he reinterpreted those math equations? And I'll tell you, it's going from having a single preferred frame for high speed or relativistic effects, saying that going from Lorenz's, there is a single preferred frame, and these effects are based on absolute velocity, to a totally different and erroneous physics model that every observer's view is equally valid physics. And it's just one example of what the big mess. As you mentioned, we went for single absolute simultaneity to relative simultaneity.
Yep.
So if you can't determine simultaneity, then you can't explain what's going on actually physically. And that was shown in the twin paradox debate and why that became such a mess. So it's the difference between the two is very simple, but it's based on just seeing what the physics change was. And,
no, when I was dealing with that, I was dealing with the mathematics, and if you want to put another layer on top of how do you physically interpret the equation, then that's another issue. I'm pointing out the fundamental equation that seems to connect Einstein and Newton is that equation I've just presented to you, and how Einstein is treating that equation seems to be different to how Newton is treating that equation. And the problem is that Einstein didn't explicitly state that equation I've shown you, and he just seems to deal with that equation in a different way to how Newtonian physics would deal with that equation. And the issue of, say, Lorentzi's theory, where Einstein doesn't tell you anything about if he's doing things differently to Lorentzi's theory. And it still ends up with people who believe in relativity, and they've got their point of view of they believe in a preferred frame, and you've got other people who believe in relativity and they don't believe in a preferred frame. So you've got people who are believing in what would be Lorentzi's theory with a preferred frame, but they are thinking that is special relativity. So you've got this other confusion added on top of it, but I'm not dealing with that issue. I'm dealing with the confusion made as you transition from how Newton deals with the mathematics to how Einstein deals with the mathematics. Other issues or other confusions added on top of it. Okay. Thank you. Cheers. Thank you. Well then.
Well, I would say that my view is that approach is very confusing, and it's the same type of problem that got us into this problem in physics, and that it's the focus on the math, which is what Einstein did, a lot of math manipulation and reinterpretation without being specific about what the physics problems were.
Yeah.
And
but physics is now mathematical.
so I would say it would be better just to talk about, hey, this is what Einstein did from a physics point of view when he went to relativity theory, and that's the change in the physics model.
Yeah, how that is a different issue. I'm dealing with the mathematics, and I'm trying to show that Einstein is dealing with the mathematics differently to how Newtonian physics would be dealing with it. And so you've got this problem of how the mathematics is dealt with, and you've got later on the problem of how the mathematics is to be physically interpreted. So if you want to go beyond what I'm talking about, that is another issue.
Okay, I'll come back. I'll come back and give you a reference, a paper that I wrote, which I think is the correct way to look at it, and is a lot simpler. So I'll put that into the chat, and if you could just make that available to people.
You're talking about how to physically interpret it. I'm concerned with the mathematics, and most of the main things.
My point is, you should not be concerned with the mathematics, because that was the problem that Einstein gave us.
Well, Einstein.
We want to just focus on the physics, and if you focus on the physics, it's really simple. Really simple.
Getting the mathematics correct is the most important thing before going on to anything else. And you've got this problem with Einstein. How does he deal with the mathematics? And I'm trying to point out what that problem starts from.
Okay, I'll put a reference to my paper, and if you could make that available later, that'd be good. Thank you.
Thank you. Cheers. Joe, bye. Right. So, hey, at the stage. Right. Good. Okay. So I can look now in the comments again. There's a nice lively debate there. So Nick wanted to get down into the physical interpretations involved, but this talk wasn't about that. It was about how Einstein seems to be dealing with the mathematics differently to how Newtonian physics would deal with it. So, and Einstein didn't explicitly make things clear as to what he was dealing with in the mathematics when he made the transition from how Newton would deal with it to how he wanted to deal with it. And so that's what this talk has been about, is trying to get the mathematics sorted out. Right, so if you people in the comments section, if you could say my name at the beginning to Roger, so I know you're referring to me, because I know is that lots of the time people just talk among themselves about their other side issues. I thought, okay. So we're going down. So going down. Let's say anything written to me so far. This is the fun one. If I was telling you this, so you got this comment. I'll just bring this one up. It's my question. The maths doesn't prove anything though, so it's just it is the point of view of some people in the distant community just to ignore mathematics, and a large part of the problem with Einstein's relativity is there's this mess being made in the mathematics, and so it doesn't help that some dissidents just want to ignore the mathematics. So I can't see any comments addressed to me. It's just people talking among themselves. Unless I'm missing anything. No, nothing. I can't see anything addressed to me. Roger. Oh, so I don't know whether it's addressed to me or commenting to somebody else. It says, Roger is doing physics magic. A sleight of hand trick. AI showed him the experiment that led to the maths, which predicts that space and time are different for moving frames, and switching to philosophy. So, well, if you want to think of physics as magic, so be it if you want to. But physics, from the mainstream point of view, is supposed to be mathematical. I'm dealing with the mathematics which the mainstream is dealing with, and trying to put a problem with that. If you want to think that's magic, so what? Roger. Yeah. Roger, at low speeds, special relativity does return to the Galilean ideas, and that is false. I've dealt with a talk previously where I pointed out it doesn't. That is something that is taught to physics students, that at low speeds, Lorentz transformations approximate to the Galilean transformations, but that is a false mathematical claim. So going back to the really beginning of what the mathematics is, which is in this fundamental equation I've just shown you, if you start working out the mathematics from that to get to the Lorentz transformation and so forth, that claim that Lorentz transformations reduced to the Galilean transformations is false. At those, when the claim for it at low speeds, that's just false. That's mathematically wrong. But it is something that is taught to physics students, that claim, that false claim. So you've got this problem of false mathematics is being taught to physics students. They're not taking it back to the very beginning, which is this fundamental equation, and showing you how relativity is dealing with things differently to that equation. And instead, they're just giving you false mathematical claims. And I've dealt with that in a previous talk. Lorentz transformations at low speeds do not reduce to Galilean transformations. So David, I don't know. No more mention of my name. Roger. Magic here again. Yeah. That says. So he's just saying. So Roger, magic here again. Well, there you go. If you want to treat mathematics is a magic and physics is magic, so what? So he says the math is based on the experiment, not on your philosophy. Well, I presented the maths which the mainstream is using from experiment. That equation is what comes from experiment. The light clock is, so say, the Michelson-Morley experiment, and that is the mathematics for it. So if you want to think that's magic, then that's it. That's the maths from experiment. And the philosophy issue would be, how would you interpret that equation? No, there's no comments to myself. There's just lots of talking between people. Sorry, Roger. So there you go. So question says, sorry, Roger, we should have responded more to your talk. Yeah. As you know, math isn't my forte. Yeah, is the problem. In the comments, people just want to talk among themselves. They talk among themselves about what they're thinking, and they're not talking about the talk I've just presented. Right, as Roger, much your presentation was mathematical. I'm much better with understanding words and concepts. Well, I don't understand why a person would want to get involved with physics if they hadn't have a strong understanding of mathematics. So physics, as we know it today, is mathematical. So Robert says, your version of relativity is magic. That is fooling no one. So, well, if it's fooling somebody, it's fooling AI. I presented the equation to AI and asked what AI, in its artificial way of thinking, thought of that, and it came back with a response that it was bridging Newtonian physics with Einsteinian physics. So if bridging from one type of physics to another type of physics, then it's magic. So what? Oh yeah, God. I just add this comment. This comment wasn't to me, and it says, "What if relativity itself is magic?" Question mark. Yeah, that's probably it. Yeah, so this professor says to me, Roger, the maths used by Einstein is Lorentz transformations. Well, yeah, transformational transformations are easy to understand in Voigt's work. Yeah, Einstein didn't refer to Voigt's work, so it's going by what Einstein says. That's one of the problems with Nick. He wanted to go by Lorentz theory and look at what Einstein changed from what Lorentz was talking about. The problem there is Einstein didn't talk about Lorentz's theory, so there's no insight from Einstein as to how he's doing things differently to Lorentz. Similarly, Einstein never talked about Voigt's work, so there's no insight from Einstein as to how he's going to deal with things differently or the same as Voigt. So it's a problem there. Yeah. And it says Einstein's interpretation made them something magic, but not related to reality. So Einstein, by not making things clear from what other previous people were doing, such as Lorentz and Voigt and so forth, Einstein didn't refer to these people didn't refer to their theories. He didn't point out what he was doing differently to these other theories. And so you've got this magic, I suppose, as Einstein makes a transition from them. Yeah. Yeah, and so Robert says when V divided by C is small, when compared to 1, the maths of Galilean frames returns, and that's false. It's just one of these mathematical claims they tell physics students, and it's just a false claim. There have been papers written on that's just another false claim made about relativity, and I've given a talk on that. Also, other false claims are made. Many other false claims are made to physics students about relativity, and that's just one of many of them. Roger. So Jim says, Roger, the maths of special relativity, SR, and LET, which is Lorentz ether theory, are attempts to explain the null Michelson-Morley experiment, which is abbreviated to MNX. Yeah, and the problem there really is that Einstein's special relativity is supposed to have started from his 1905 paper on that called On the Electrodynamics of Moving Bodies. And Einstein makes no reference to Michelson-Morley experiment. So it's an inference that comes later than 1905, that what Einstein is talking about must have been the Michelson-Morley experiment when he wrote that paper on special relativity. And so in order to confirm that, they asked Einstein, was he aware of the was he aware in 1905 of the Michelson-Morley experiment? And Einstein just contradicted himself. In one interview, he said he didn't know about it, and in another one, he said he did know about it. So all of this basing special relativity on the Michelson-Morley experiment is just retrospecting the history onto it, because if you just read the paper of special relativity, there is no mention of the Michelson-Morley experiment. It seems to instead be based upon Einstein coming up with these thought experiments without it actually being based upon any actual experiment. Whereas, of course, if you go to Lorentz, when he was forming his Lorentz theory, he was basing it upon the Michelson-Morley experiment. So you have the difference between what Einstein is doing and what Lorentz is doing. Yeah, great. No more comments to me. Great. Oh, another one. Should I? Roger. This professor again. Einstein used Voigt's nonpotence for Lorentz transformations. Lorentz admitted in a book and in a letter to Voigt that he got these auxiliary variables from Voigt, yeah. But Einstein didn't say that in his 1905 paper on special relativity. Einstein doesn't actually give any references in that paper from what he was working from. So when you go by Einstein, it's just a total mystery of where he's getting all these things from. It's like he just dreamt it all up. So it's Einstein once again has left to confusion. Ideally, science paper, physics paper should be giving references to what you're working from. But Einstein, for some unknown reason, seemed to have an exemption, and he was just allowed to say whatever he liked without saying where his information sources were. Which is, in a sense, is magic, really. Einstein, most people writing a physics paper nowadays wouldn't be able to be allowed to submit a paper without saying what is your information sources. So Einstein had the magic of he was able to publish a physics paper without saying what he was working from. More magic. Hey presto, abracadabra. Okay, another one for the professor. Okay, in Voigt's work, the auxiliary variables called Nerité's Lorentz transformations have a clear meaning that everyone can understand and everyone can agree with. No magic, no error. No, I disagree with him on that. They've completely misunderstood it, as I've tried to point out, about this duality between Newton and Einstein in this mathematics. They have completely misunderstood that, and they are teaching mathematical mistakes to their physics students. Okay, so I think I managed to catch up at last. Right, so anybody else could put their hand up. They got James and Vladimir in the green room. I don't think they want to say anything. No hands are coming up. Great. Anybody else? Oh, I got 2 comments. Oh, no, I don't. I got 2. Oh, God. I've got one more comment here. Oh, yeah. So I've got from Nick Percival a private comment. So I'll just add that to the general comments. Nick. Post. Hopefully that comes through. This is a comment from Nick. It was sent to me in the private comments. Here we go. Bring it up. I show. It's from Nick. The references to Nick's papers are at that address. And he says, disregard the paper's title as that was just to get by the high level censor. But I don't know whether that's relevant to what I've been talking about today, because Nick, as we've dealt with, wants to deal with the physical interpretation of the theories rather than actually get to the nitty-gritty of trying to sort out the mathematics. So today's talk is about the mathematics. I don't know whether Nick was addressing that issue. He wants to go on to a different issue. Next, what we got? Oh, we've got a hand up, James. James. Hi, James.
Hi, Roger. I wanted to ask about the slide that you just have up. Could you put that slide back, or?
Okay.
The equation at the top appear. I missed the very beginning of the talk, so excuse me if this is out of line. But the question I have by looking at that equation, well, you're changing it now. It's gone.
I'm trying to go back to where it's come from. It's sort of this is the physics setup.
Well, the equation that you had up there showed what looks like a Pythagoras type of theorem.
Yeah,
Are you actually saying that uh, uh, the distances implied by the use of the Pythagoras theorem um, uh, well, it seems like you're assuming some things like the two terms to the right that are squared,
yeah,
that they're orthogonal, number one,
yeah,
um, and that um, somehow there's some meaning to the hypotenuse
yeah,
of that triangle.
yeah,
You see what I'm saying? It's just perhaps if you could clarify that a little bit.
yeah.
Uh-huh.
You see the slide up now. It's the setup for which is given in relativity textbooks on how you derive the time dilation equations, and some distance disagree about it being time dilation and say it's clock dilation. And so in this diagram, you've got light bouncing up and down between receiver, light source to mirror, then back to receiver, and that's going vertically up and down, and that's considering this astronaut to which that is stationary, so the light is just going up and down. But as the astronaut is moving from the point of view of the observer on Earth, then what the observer on Earth sees is this triangle. The light moves at an angle, bounces on the mirror, and then bounces back down again. So light is moving at in a Pythagorean triangle. And that's pretty much standard what's in relativity textbooks. The issue is the setup of the light source receiver and the mirror is moving, and that whole setup is moving, and the light is moving along with that. And so you're having the light as observed from the observer on the Earth as traveling along this hypotenuse of a triangle, which is a distance s going up and another distance of s traveling down again. So, but from the point of view of the astronaut, he's not seeing that, not seeing the light moving in that way. Instead, he's just seeing the light moving up and down from the triangle. And so, based upon that setup, that's how they get the mathematics for the fundamental issue of the maths for special relativity.
Is any of this based upon actual measurements, or is this all entirely hypothetical?
This is supposed to be what they get. This is the simplified, dumbed down version which they teach physics students. This setup is supposed to be representing the Michelson-Morley experiment. You can consider it as a light clock, where the light is bouncing, moving up from the light source to the mirror, being reflected back down again, and hitting the receiver, and bouncing up and down again. So it's a light clock. You're counting the number of times the light moves up and down between the bottom and the mirror at the top. So it's a clock, a light clock, as they call it.
Okay, thank you.
Thank you. Yes. Okay. Exit full screen. Okay. Thank you. Thank you, James. Okay. Right. Next. No more hands. And have I missed any more comments turn up? Yeah. No, I don't think there's any more comments to me. And in the green room, there's nobody else putting up a hand. So I think I can bring this talk to an early close, which is good, because I can then go on to this other talk, which is starting at 5 o'clock. I might be awake for that one. Normally, I'm a bit tired after all this. So if we can finish now, thank you, everybody. Another attack on relativity. This time it's been a mathematical attack rather than what Nick wanted which was a physical interpretation attack. So thank you, everybody, and I can end the session now. Thank you. Bye then. Bye. Okay, thanks, question. Bye. Thank you. Okay, some people say thank you. Thank you. Bye. That. All right, thanks, Roger. Okay, thank you. Thank you to everybody else. Cheers. Bye. End session.